The ammeter indicates the amount of current flow by a display on the digital multimeter. The greater the current, the larger the value in the display. The maximum current that an ammeter can measure is indicated by the highest number on the display multiplied by the meter switch setting. The ammeter has a positive and a negative terminal to identify its polarity. The schematic symbol for the ammeter is a circle with the capital letter A in the center and the polarity markings outside. In order for the display to indicate a positive value, the positive lead of the meter must be connected to the more positive point in the circuit. An ammeter must be connected into the circuit so that all the current to be measured goes through it. The meter is said to be connected in series with the circuit load. A series circuit is an arrangement of components which provides for a single path of current flow. The first step in connecting an ammeter in a circuit is to de-energize the circuit by disconnecting the power source or opening the switch. The second step is to open the circuit at the point where you're going to insert the ammeter. The schematic diagram indicates the ammeter will be inserted between the lamp and the negative terminal of the power source. Look at the terminals of the battery and the terminals of the ammeter. Notice that they're both identified with positive and negative symbols. Since the current flows from the negative terminal of the battery through the circuit and back to the positive terminal, it must also flow in this direction through the ammeter. Connect the wire from the negative terminal of the battery to the negative terminal of the ammeter, and the positive terminal of the ammeter to the negative terminal of the lamp. Re-energize the circuit by closing the switch. The lamp should light, and the ammeter will indicate the amount of current flow in the circuit. As you may recall, voltage is the measure of the potential difference between 2 points in an electrical circuit. Voltage is measured in a device called a voltmeter. Like an ammeter, it has a calibrated display that indicates the amount of potential difference in volts. This potential difference may be a voltage rise, which represents energy furnished to the circuit, or a voltage drop, which is the energy consumed by some element in the circuit. The schematic symbol for a voltmeter is a circle with a capital letter V inside and a positive and negative polarity symbol outside. Most electrical equipment is color-coded to make it easy to identify polarity. The negative terminal is black and the positive terminal is red. Remember, when connecting test leads to a voltmeter, to follow the color code for polarity. The black negative test lead must be connected to the black terminal, and the same holds true for the red positive lead. Always make sure the voltmeter can withstand the voltage you're measuring. If the voltage is too high for the meter, it will be damaged. Also, make sure the range switch is selected for the proper range. When measuring voltage, the circuit is not open. Always connect the negative or black probe to the point nearest the negative side of the source, and the positive red probe to the point nearest the positive terminal of the source. The voltmeter is connected across a circuit element to measure the potential difference. Connecting a voltmeter backwards will cause a negative sign to be displayed on the meter. One word of caution: whenever using a voltmeter, make sure you hold the test leads by their insulated handles. Since the circuit you'll be working on won't be de-energized, touching any other part of the lead could make you a part of the circuit and cause a shock or possible injury. To measure the voltage rise in the circuit, connect the voltmeter across the source, in this case the battery. To measure the voltage drop in the circuit, connect the voltmeter across the load. In this circuit, it's the lamp. Voltage cannot be measured across a closed switch because there is no electrical energy being used between these 2 points. Voltage cannot be measured between 2 points in a conductor because of its low resistance. The voltmeter would indicate 0 volts.